we're going to look at a specific application of the sum of angles formulas. And specifically, what we're looking at is we're looking at combining two sinusoidals, so sine bx, cosine bx. And the important thing here is that the period of both of these is the same thing. It turns out that when you have a sum of sines and cosines like that, you can actually write it as a single sine term. And so these are the formulas that you need to use, but we're going to show you the logic behind these formulas, and then we'll do an example. Okay, so here are the formulas, and so where does this all come from? What we're going to do is we're actually going to look at the right-hand side of this thing. A sine of bx plus c. And you'll notice that in this case, this bx plus c, the x term is not isolated. It's not like the other one was like b times t minus c or something like that. In this case, it's in this particular form, so do pay attention to that detail. And so what we have here is we can just use the sum of angles formulas. A times the quantity, so this is a sum of angles in the sine function, so sine of bx cosine of c plus cosine of bx sine of c. And now we're going to distribute the a. And we're also going to put the sine bx term on the end. So a cosine of c sine bx plus a sine of c cosine bx. Now the reason I've done this is because if we compare this equation to this equation right here, we'll notice a pattern. M is going to be this part. It's the coefficient of the sine bx, and n is going to be that part, the coefficient of the cosine bx. And you can see right here, if m is equal to a cosine c, and n is a sine c, that by dividing both sides by a, m over a is cosine c, and n over a is sine c, that's a derivation of these two values. M over a is cosine c, that's this one, n over a is sine of c, that's that one. But that still leaves us with the question, what about a squared equals m squared plus n squared? Where does that thing come from? Well, it's actually just a rearrangement of these two expressions. And the trick here is to use the Pythagorean identity. Sine squared plus cosine squared equals 1. So we'll slide in over here. Sine squared c plus cosine squared c equals 1. Right? Well, sine squared is going to be n over a, so n over a squared plus m over a squared equals 1. N squared over a squared plus m squared over a squared is 1. If you multiply both sides by a squared, n squared plus m squared equals a squared, right? So all of these formulas, they simply come out of plugging stuff in and moving things around until you get the parts to match up. And then also in this last part, just recognizing the Pythagorean identity again. Write 4 root 3 sine of 2x minus 4 cosine 2x as a single sinusoidal function. And here are those formulas. So the first thing we need to do is match everything up. We have m is equal to 4 root 3. We have n is equal to negative 4. So the first thing we want to do is we want to calculate a. So a is going to be equal to the square root of 4 root 3 squared plus negative 4 squared. And we just need to work that out. 4 root 3 squared, so the 4 squared is 16. The root 3 squared is 3, so 16 times 3 is 48. Square root of 48 plus negative 4 squared is 16. 48 and 16 is 64. The square root of 64 is 8. So that takes care of the first part. For the next part, we need to figure out this value of c. What value of c are we going to get? Well, we have cosine of c is equal to m over a, so 4 root 3 over 8, which is the same as root 3 over 2. And then sine of c is going to be n, which is negative 4 over 8, which is negative 1/2. We need to figure out what angle c satisfies those properties. First thing to look at are the quadrants. In this case, we have the cosine term is positive and the sine term is negative. The cosine term corresponds to the x-coordinate, so the x-coordinate is positive. The sine term corresponds to the y-coordinate. The y-coordinate is negative, which means you're down here in quadrant 4. And so this is going to help us because we can get the reference angle, but then this knowing what quadrant it is tells us what the actual value is. So now let's think. Cosine of a reference angle is root 3 over 2. Sine is going to be 1/2. I'm actually going to draw a little triangle since we're looking at both of them. So the root 3 over 2 side is horizontal. The 1/2 side is vertical. Now remember, the angle is technically in the fourth quadrant, so it's flipped over, but I'm just drawing it this way because this is conventional. Question is, what is that reference angle? Well, that reference angle is going to be 30 degrees. The 30-degree angle here, just a smaller value, and the 30 degrees is also pi over 6 radians. So that tells us our reference angle. Since we're in the fourth quadrant, we have to go all the way around and then come back by that reference angle. And so 2 pi minus pi over 6 is 11 pi over 6, and this is going to be our value of c. And so when we put it all together, this expression right here, which I'm going to rewrite, 4 root 3 sine of 2x minus 4 cosine of 2x is equal to a, which is 8, times sine of bx, the b is the same throughout, 2x, plus c, plus 11 pi over 6. And if you were to take the sum of angles formula and apply it to this and expand it all out, you should get this.